Okay, and now we are looking at your warm-up on page 44 for your quiz today. The first section of this warm-up is about kinetic molecular theory, and you're marking true or false, and if it's false, rewrite the statement. So statement 1, gas particles are very large and have very little space between them. That is false, and if we go back and look at our notes on kinetic molecular theory, back on page 37, it said that gas particles are very small with large distance between them. So, gas particles are very small and have large space between them. Number 2, when gas particles collide with the sides of the container, it causes temperature. Again, we can go back and check our notes on page 37. Page 37 says, when gas particles collide with the side of their container, that causes pressure. So that means number 2 is also false. And we can rewrite that when gas particles collide with their container, it causes pressure. We can go look at number 3. Number 3 says gas particles move little. And number 3 on page 37, gas particles are in constant, rapid, random motion. So this is also false. And at this point, I don't think we need to rewrite every single word in the sentence. We can just say that they move constant, rapid, and randomly. I guess these should all be ly. Constantly, rapidly, randomly. There you go. Number 4, gas particles either attract or repel each other. Again, we can go look at our notes on page 37. Gas particles are in constant... oh wait, sorry, that's the wrong one. Gas particles do not attract or repel each other. So that one's false. They don't attract or repel. And number 5, the average kinetic energy of gas particles is equal to its pressure. Well, I already know that one's false because we already said pressure was when gas particles collide. So this one's definitely false. Average kinetic energy is not going to be pressure. We are probably going to have to go check our notes to see what it actually is. Average kinetic energy equals, I don't know, let's go check our notes. Page 37 says the average kinetic energy is equal to the temperature. Oh look, earlier when we took these notes, it says at the bottom, I even highlighted it, you must memorize these 5 postulates, they will be on quizzes and tests. And those 5 things were all what we just went over in this part of the warm-up. Average kinetic energy equals temperature. Gas particles move constant, rapid, random motion, don't attract or repel. When they collide, that causes pressure. They're very small with large space between. So yeah, you need to know these things. Notice they were all 5 originally false. We had to correct. We had to correct all 5 of them. Okay? And you do have to know these for your quiz. You do have to know these for your quiz. Let's move on to the guess boxes, though. Number 2 here says, what would happen to the volume if pressure of 3.2 atm and 9.1 liters increased to 4.7 atm? So we have 3 givens, 3.2 atm 9.1 liters and 4.7 ATM. Even if you don't know that ATM is pressure, they tell you the pressure of 3.2 ATM. So that tells you this is pressure, and the other ATM, that tells you both of those are pressure. And they didn't specifically say that liters was volume, but they do say what would happen to the volume. And this is the only thing here, and you probably know by now because you're in 10th or 11th grade that liters are volume, because you've been using liters for probably most of your life. So hopefully you know liters are volume. Liters are volume. Notice they're saying that the pressure of 3.2 increased to 4.7, so this increase 2 is telling me that 4.7 is after a change, so that's number 2, and 3.2 is number 1. And they're asking what would happen to the volume, so volume is our unknown. What would happen to it, meaning after a change, so that's also my second one, and 9.1 is my first. I need an equation that has 2 P's and 2 V's. So if I go look at my, you can actually look at the equation chart at the back of your book. It's on the inside of your periodic table cover. And we're looking for one with 2 P's and 2 V's. That's this one right here. 2 P's and 2 V's. So P1 V1 equals P2 V2. And it may help to recall that even though it doesn't have times signs in there, these are multiplied by each other. We can go substitute. Instead of P1, I'm going to write 3.2. That's times, instead of V1, I'm going to write 9.1. Equals, instead of P2, I'm going to write 4.7. And V2, I don't know. I can write V2 if I want. I could also just write, like, that could just be X. You could just write X if it bothers you. Either way, you're going to have to multiply these. 3.2 times 9.1, which is 29.12. That equals 4.7x, basically. So to solve for x, to isolate x, you're going to have to do the opposite of what's happening to x right now. Right now, x is times 4.7. The opposite of that is to divide by 4.7. If you divide on one side, you have to do it on the other side. So I'm really doing 29.12 divided by 4.7. And I get 6.195, which rounds to 6.20. Oh, we need units for this. How are we supposed to do these units again? This is a volume. And remember, your two volumes should match units. So if they tell you volume 1 is liters, that tells you volume 2 should be liters. And that also tells me my answer should be liters. For this final problem, 320 milliliters, 320 milliliters of gas, 32 degrees Celsius, and 48 degrees Celsius. Hopefully at this point in your life you know that milliliters are volume and Celsius is temperature, but even if you didn't know that for sure, they use the word temperature in here to talk about Celsius. And they're also using the word volume for the other thing. What would the new volume be? So they're asking us for volume, and we said that new is code for 2, so that's V2. The new volume is V2. Which means this other one was V1. And notice that if V1 was milliliters, V2 should also be milliliters. Our temperatures, it says 32 degrees, and then it rose to 48 degrees. So it's starting at 32, then it's rising to 48. It is going to be 48 second. It's going to be 32 first. And one final thing, we cannot use Celsius in our equations in this unit. We have to have Kelvin, so that means we're going to have to convert it. So, again, Kelvin is Celsius plus 273. So we take our Celsius, we add 273, So 32 plus 273 is 298 Kelvin. Or sorry, 295. 295 Kelvin. That's also wrong, isn't it? I'm sorry. I should just not do this in my head. It's 305. I'm really sorry about that. Okay, and 48 plus 273 is 321 Kelvin. And once you have your two numbers in Kelvin, you don't need the Celsius anymore. You could even cross the Celsius out so you don't accidentally use it. You need 321 and 305. We also need a formula. I have V1 and V2. I have T1 and T2. So I have two V's and two T's, and that's this formula. V1 over T1 equals V2 over T2. So your equation is V1 over T1 equals V2 over T2. And we're going to go substitute in. Instead of V1, I'm going to write 320. Instead of T1, we use the Kelvin, so 305. Instead of V2, we don't know V2, so we're actually going to keep using V2, or you can write an X if that makes you more comfortable. And instead of T2, we're going to use 321. Again, if you know how to use the butterfly method, if you know how to cross multiply, be my guest. I prefer to simplify this, so I do in my calculator 320 over 305 first, which is about 1.049. That equals V2 over 321. If you're going to isolate V2, then that means you've got to get it by itself by doing the opposite of what's happening right now. So if it's divided by 321, the opposite of that is times 321. If you do it to one side, you have to do it to both sides of your equation. So really, we're doing 1.049 times 321. We get 336.7 and rounds to 0.79. And again, you need a unit. We're going to use the milliliters that we had up there. All right, time for your quiz.